Dear students, this is the chapter number 3, Trigonometry. In my last video, I have discussed about the T ratios and the allied angles, okay, and the different quadrants. Okay, today I am going to discuss one of the most important topic of trigonometry. In this case, we will see that how many angles where the values are equal. Suppose if you have to given sine 30 degree means sine of pi by 6, that is equal to 1 by 2. So is there any another angles where its value is equal to 1 by 2? Yes. Students, there are so many angles where its value is equal to 1 by 2. As you know that sine and cos are periodic functions and its time period is 2 pi. Okay, that means I want to say that sine of 2 pi plus theta is always equal to sine theta. Similarly, for the cos 2 pi plus theta, that is always a cos theta. Okay, so except of 2 pi, is there any another angles? Yes, there are so many angles. There are so many hidden angles. Okay, now how to find those angles? This is a main problem. So I have written here, it's an important formula. In this case, he said that if sine alpha is equal to sine beta, suppose alpha is a one angle and beta is another angle. Now how we can find the other angles? So this formula is given by some mathematician. He said that if sine alpha is equal to sine beta, then alpha is equal to n pi plus minus 1 ki power n into beta, where n is any integer. Z means set of the integer. So n is an integer. Okay. So in this case, you can find the different values, different angles for the some angle. When one angle is given, you can find the different angles. Similarly, another formula is if cos alpha is equal to cos beta. Okay, then in that case alpha is equal to 2n pi plus minus of beta, once again where n belongs to any integer. In the third part, he said that if tan alpha is equal to tan beta, in that case alpha is equal to n pi plus beta. Now the question is how to change these T ratios, how to use these formulas, okay, in your practical. Now see, this is exercise 3.4 and this is question number 1. In this case, he said that if tan x is equal to under root 3, then what are the other angles here? What are the values for x? Okay, as you know that tan under root 3, that is equal to your at tan of 60 degree. That means it's a tan of a pi by 3. Then in this case, you can use tan alpha is equal to tan beta. That means you can say tan alpha is equal to tan beta. In that case, alpha is equal to n pi plus of beta. Then, so this is a suppose alpha and this is a beta. So x is equal to n pi plus pi by 3. Okay, where n is any integer. Where n is an integer. Okay, this value is called general value. Why it is called general? Because here you can put n is equal to either 0, either 1, either 2, either minus 1, either minus 2, etc. Any value. So that's why this is called your general value. Now I am going to find the principal values. Principal values means particular values. Okay. Now let us suppose when n is equal to 0. So when n is equal to 0, naturally it's a 0 into pi plus pi by 3. So this is the first of the value. That means x is equal to pi by 3. So this is the first value. Similarly, if you want to find the another value, then in that case put n is equal to 1. So when n is equal to 1, see what's happened. X is equal to, that is equal to your pi plus pi by 3. And if we solve this one, 3 plus 1, 4. So it's another angle, that's a pi by 4 pi by 3. This is another angle will be known. Similarly, if you want to use n is equal to 2, see what's happened. X is equal to, it's a 2 pi plus pi by 3. So 3 to the 6 plus 1, so that is equal to 7 pi by 3. Similarly, you can find the for another T ratios for the sine theta, cos theta, whatever you want to solve. You can use these formulas and you can find the different angles. So this is a question number 1. This is a second problem. In this case, he said that secant x is equal to 2. As you know that secant of 60 degree, that means pi by 3 gives the answer is equal to 2. Okay. So, but we have the formulas sine, cos and tan. So, we have to convert secant into cos x. So, cos x is equal to cos of pi by 3. Once again, you can use the formula cos alpha is equal to cos beta. That means alpha is equal to 2n pi plus minus of beta, where n is any integer. And I am going to use this one. So, x is equal to 2n pi plus minus of beta. Beta is this angle. This is suppose this is alpha and this is beta. So this is your pi by 3, where n belongs to z or i. These are the notation for the integers. So this is called your general solution. Okay, but we have to find the principal solutions. If you want to find the principal solutions, then you have to give the values for n. So let n is equal to 0. See what's happened. So x is equal to plus minus of a pi by 3. So here are the two values. One of them is a positive and one of them is a negative. Okay, pi by plus minus pi by 3. Similarly, if we put n is equal to 1, see what's happened. X is equal to 2 pi plus minus of a pi by 3. Done. So when x is equal to 2 pi plus pi by 3, this is the first case, and the second case is x is equal to 2 pi minus pi by 3. So by this method you can find the different angles. 3 to the 6 plus 1, so it is equal to your, one of the values is 7 pi by 3, and the second is 3 to the 6 minus 1, so it is equal to your 5 pi by 3. Similarly, you can find the so many angles, so many values. So this is the basically use of these formulas. Sin alpha is equal to sin beta, cos alpha is equal to cos beta, and tan alpha is equal to tan beta. So this is the basically use of these formulas. So by these formulas you can find the different angles. That's all.